Welcome to the second session of CDIO, and of course we love to see you, Mats, all the time, online and face-to-face in Egypt, inshallah, and wish you all the best. We always enjoy your actually presentations, and we learn a lot from this. Hopefully we can learn that face-to-face in January. So today we are going to continue session 2 about the CDIO implementation and online session that's led by Professor Mats Hansson from Sweden. So the floor is yours, please. Go ahead.
Thank you very much for the nice introduction and the nice words. I must say I also really appreciate to be on board on this Center of Excellence for Energy, and also work with you in Cairo and Egypt with the universities. So yes, I'm looking forward also to present this session. Actually, we have divided this 2-hour session into 2. Each of them is 1 hour. And as before, we have a 5-minute break between the sessions, and no assignments, but I will present some assignments during the presentation. And I repeat also, I'm looking forward to the face-to-face workshop. So some of the contents are still a teaser, but I also hope that most of what we share with you is also applicable already today or tomorrow, and for the next semester and the next type of courses. So please start, implement whatever you find useful. I also said, as I said before, during this session, I have some material created from other people in the community, and it's fair to share. So, and you are also able to use the material as you like, and you can also sign that it's coming from the CDIO community. Today we will cover the syllabus, also one of the cornerstones, and also the learning outcome framework. And so this will be the first hour when we really focus on the CDIO. The second hour, as I said, will be a little bit more into the future. We have some new proposals for you, and I hope you like to listen to the proposals. I like the ideas we have was coming up last week. So a little bit of recap first. We are focusing on engineering education, but not a specific engineering subject or engineering program. We think that all CDIO methodology is applicable for most of the engineering programs. We are also focusing on creating graduate students who can lead. Leadership is one of the messages in the CDIO community. Also be a good citizen, so you understand that you are working in the society and the international environment. So this is just a recap. As I said a few seconds ago, this is a reference model, not a prescription, so you can use whatever you find useful and discuss it with your colleagues, your students and peers, and people from the society, from the industry, whatever you want to share, and then try to apply CDIO as a reference model. And you should be the owner of your own model, so to speak. I think we also have a toolbox that we can share, and the CDIO community, by the conferences, by the CDIO website, have a lot of interesting tools for you to work with. And as I said last time also, we encourage everyone to to research their own education experience. So you can make research in engineering education research, and you can publish your result, you can communicate your result. So please be active to share your findings with colleagues and with the CDIO community. So today we are talking a little bit more in detail about the CDIO syllabus. And the syllabus is all about what we should teach. CDIO standards we covered 2 weeks ago, and that's how we can organize the development of the curriculum and also the delivery, how to deliver it. Then we have the curricular design process that we should discuss later on, going from what to how we should do this. And of course, we have the self-evaluation. We need to have a feedback loop and in different ways for each course, for programs, accreditation, and so on and so forth. So CDIO have some standards for self-evaluation also. So what is the professional role and practical context of the professional, the need? We were talking a little bit about the didactics. I think you can find a link between the syllabus and also the identity and the legitimacy that we were talking about last session. So the identity and legitimacy is also connected to what. So that's the need. We have to answer that question. And also this is not before, this is actually when they graduate. So we have time for the student to learn the skills and the knowledge, and it's an integrated curriculum. So I think the program, if it's a bachelor program, master program, PhD program, I think the word program in this context is important because it's a profession we are going to, the engineering profession we are focusing on. So it's not that they should master a math course by itself or a solid mechanic course by itself. It's the integration in the program. So we are focusing on, first in the syllabus, on the program learning outcomes. And then, of course, also going back to the selection and the communication in the didactics we were talking about, how can we do better to ensure that the students learn these skills? And then we are coming from the syllabus to the curriculum. So I took these 2 slides to describe what some people think is the difference between science and engineering. Science investigates what is already is, and engineers create the future. And Thomas Edison is also a good quote because he was, testing. So he was trying, a little bit on ad hoc, but still. And sometimes engineers are like Thomas Edison. I showed this slide before. I got the question about also feedback, but if you're looking into the different stages in the development process, in the CDIO process, conceive, it's about the customer needs, technology, enterprise strategy, regulations, concept and technical plans, but also in the customer needs, we need to go to the local society on the country level, maybe a district or a city, and ask for the needs for the graduates. Because one of the cornerstones is also that we are responsible as a university that the students who graduate are employable, so they can get a good job after graduation, and they should be in the business for maybe 30 years, 40 years. So we need to ensure that we graduate students who are employable. So I'm coming back to the customer needs, because we have done some investigation what the corporate world expect from the university. The design is, of course, the construction of the program. If we're talking about the program level, what courses should be included as compulsory or elective? It's always a debate, a fight in the curriculum meetings with the faculty about what should be included and what should not be included, especially the compulsory courses versus the other courses, elective. The implementation, going from teaching to learning is one way to see it, the different processes. Now we are also, the implementing is also facing the face-to-face and the online, how we should implement the education process. And also connected to the operator, of course, to run the program. So we should have done a job before we actually deliver the program. So many people are designing the curriculum, and we are making a lot of activities before we actually deliver the education. And I'm coming back to some of these bullet points. You can read them, but I'm not going through them everyone. But I promise you, I'm coming back to some of these, because I think it's a lot of thinking behind those bullet points. I got a question after the last session about feedback loops. And of course, even if this conceive, design, implement, and operate seems to be linear, it's not linear at all. It's a lot of feedback loops that you learn from the present, and then you change your program, you change your courses, you change pedagogy, you change materials, and so on and so forth. But I will also add on the feed-forward loop in this control system. So already when we conceive the program, we conceive the curriculum, we can feed forward ideas to the design, implement, and operate phases. I also propose that you can use this conceive, design, implement, and operate on a course level. So when you are going to design a new course, you have to conceive, you have to design, implement, and operate the course. But I would propose another use for the CDIO, and I'm not quite sure if it's useful for you to understand this process or this methodology. I thought about it a couple of days ago when I was going to make dinner for this holiday we have. And you can use conceive, design, implement when you're cooking, because conceive is about what you like to eat. You have some ideas that you really, this night I want to eat a really good dinner. And I have friends and so on and so forth. So you have some ideas how to do this cooking to really deliver some really good food. And then, of course, you design. That's making the recipe. Some are looking up the recipe in a cookbook. Some are doing it ad hoc by themselves. That's fine. But you have to design something. And then you make the food. You're cooking. And then, of course, in the final end, the operate is eating everything. And then feedback. Was it good? Was it tasty? And then next time you have learned something, so you can conceive, design, implement, and operate the next dinner. And hopefully that you can feed forward also some of the ideas. So I'm not quite sure if it's useful for you, but you can use CDIO in many, many different situations and do the methodology to yours. So now, introduction to the syllabus. What is the full set of skills and attitudes that the students should possess when they graduate from the university? At the level of proficiency, how good should they be? And in addition to the traditional engineering discipline knowledge. So it's a little bit wider because you are also looking into personal and interpersonal skills. We were talking about this also before, but because the syllabus is also connected to the standards and how to do it. So the syllabus is to educate students who understand how to conceive, and how is related to the process. So the second line here, how to conceive is the process. How to conceive, design, implement the process. So we have to focus on the how. But we also have to focus on the products, the results from the engineering work, the products and the systems and the processes. And that's the product. And then in the CDIO, we emphasize on the team-based engineering environment. We know that every product and process that is going to be conducted will be in a team-based engineering environment. And of course, the team is by people in there. So your personal skills need also to be addressed. So the self. So here is the underlying need to the program learning outcomes for engineering graduates. So the syllabus that the CDIO 2.0 propose, and this is always under discussion, and we have syllabus 2.2 and others. But I will also stress that this is only a framework. So you should take whatever you find suitable from this list and make it your own. So every program, every university, every program should have your own syllabus. So this is just an idea to check if you want to have this disciplinary knowledge and reasoning. That's obvious. And we don't tell in the number one which disciplinary knowledge should be included. But we stress that it should be based on scientific findings. So engineering education should be based on science. And as I said yesterday, or 2 weeks ago, sorry, it should also be based on art in KTH. Science and art, minds and brains and hands, minds and hands in MIT. So engineering is to combine science and art. We should include the personal and professional skills, interpersonal skills like teamwork, and the CDIO or complex systems. How to operate leadership. I was talking about leadership, for example. An engineer is a leader. So this syllabus was created some years ago by MIT, KTH, Chalmers, and Linköping University, the first version of it. And we did it also in 2 or 3 more layers in detail. So for each of these 1.2, 2.2, 4 point something something, you can read more. And when you do this, you should also be aware that this is a job that you need a lot of faculty members and also students to be included in. So the ownership of the syllabus should be shared by many of the faculty members. So you should be very interested in the full program syllabus, even if you are teaching one single course in that program. So, and the syllabus is also, of course, the basis for course design and assessment, because this is the specification of the program. I will probably share with you when we designed the new university in Moscow, Skoltech, because that was a really exercise, because the university didn't exist. It was a brand new university, and it was many people who had some ideas of this new university for the future. And I was responsible for this process to make the first set of master program and PhD program at Skoltech. And we did our own syllabus. So we had the CDIO syllabus, as you can see here, as a reference model. And then we have a lot of faculty meetings between MIT and others to create our own. And it could be interesting for you, I think, if I share it with you some other times, and we can discuss, because it's quite different from this reference model. So what I think you have done also in Egypt, in your universities, is to go out to the students, alumni, and faculty and leaders from the industry and ask what they expect from the graduate engineering students. We did it at KTH, Chalmers, and MIT, and you can find a diagram looking like this. And here you can also see the 1, 2, 3, 4, 5. So the scale, if we expect the student to have experience or been exposed to just introduction to the subject, or if they are more proficient. And number 5 is okay to be a leader for innovations in the area of interest. So if you have some areas of interest and looking for graduate students who are able to actually lead or innovate already at the graduation level, that's hard to come up to that scale. And I'm not going into detail in this slide. I hope during the face-to-face workshop that we can work on your own and compare with others. So again, I have a similar one for Skoltech, and we have new ones for KTH, and because it's always updated. So I skip those, and you can read them later on when you got to the... So with that introduction to the syllabus, I want to leave for a 5-minute break, and then when I'm coming back in 5 minutes for the learning outcomes framework. So coming back in 5 minutes, and I take a glass of water. Thanks. So the second part today is about the learning outcomes framework. It's also sometimes called the intended learning outcome, or sometimes also learning objectives. So it's a slightly different names on the same thing. I think it's someone who hasn't muted the microphone. I can hear some background noise. Anyway, so the intended learning outcomes is also very closely connected to the syllabus. because the syllabus was describing what the students should be able to do after the completion of the course or program. I should actually change this course to program or program/course, because it's mostly connected also to program learning outcomes and then course learning outcomes. So you need to be able to do the learning outcomes, you first need to have the syllabus. Obvious, right? So don't start with the learning outcomes without knowing what the syllabus is stating for you, because then you don't know what you are going to do. But when you know what you are going to do, you can do it by formulating the learning outcomes. And there are some tricks to formulate the learning outcomes. And I would say personally that it was not easy when I faced this the first time in the 90s, 25 years ago, something like that. It was really hard. And we also found when we introduced the learning outcomes framework at KTH and elsewhere, that many faculty members were struggling to formulate their learning outcomes. And once they formulated, maybe some of them never looked at them again. But I should really encourage everyone to use the learning outcomes, both for themselves to understand what they are doing and what the students should be able to do after graduation, and then, of course, using them actively when they later on design the actual course. We are going to coming back how to formulate them. It's also important that the learning outcomes are connected to the activities that should be used to obtain the learning outcomes, and also the assessment, the testing. So the assessment of the students to really be able to understand that the students master the knowledge and the skills that are formulated in the learning outcomes. So one test is actually to see if you assess the learning outcomes you have stated. So that's a check you can do. Learning outcomes should be result-oriented. What is the result of the teaching learning process? As I said just a few seconds ago, possible to assess. They must be possible to assess, otherwise it's not worth to have them. Placed in a suitable and realistic level. I also want to stress that one. You have to understand the status of your students. So if you have students in the classroom who have the previous knowledge and a chance to come up to the learning outcomes that you have formulated, it's very, very hard for the students, and even for the faculty members, to have students in the classroom who don't understand what they are exposed for. So they should be realistic. And you have to be dynamic as a faculty member to understand who is in the classroom. It's also based for quality assurance. Assessors and people who are looking into your curriculum are looking to the quality of the learning outcomes framework and how it assessed and how realistic the outcome is. And of course, number E, you should understand them. It's not always you understand your own learning outcomes.
Excuse me, Matt.
Yes.
Are you sharing screen?
Yes.
I think you're sharing your video.
No, I do exactly what I did last hour.
Dr. Muhi, the screen is already shared and we can see the screen.
Maybe it's in my problem. Okay, I will check my computer. Sorry.
Okay. No, it's okay. Please please interrupt if we have some problems on my side or your side. That's perfectly fine. Thank you so much for.
It's okay. Thank you.
here are some mistakes that we did before. When we formulated the learning outcomes, we didn't look into this what the student should be able to do. We were more describing that our course is about solid mechanics, this one and this chapter number 2 and chapter number 3 and so on and so forth in the textbook. And that was the description of the program was by describing the subject instead of what the students should be able to do when they have graduated. So you have a very simple couple of words, should be able to do, should be able to, and then you should have a verb, and then you are on the right track for writing good learning outcomes. I shouldn't read everything in this slide. You can read it yourself. I will comment on number 2, taxonomy, to find these suitable words on the right level. And of course, the first one to formulate was Dr. Bloom. And sorry for this messy picture. I'll just give one example here. I have 5 or 6 or 7 different taxonomy because they have developed over time. But I think for historic reasons, you have to understand the Bloom's taxonomy. From the bottom, remember, understand, apply, analyze, evaluate, create is of course different levels of understanding. The simple one is just to remember, memorize. And then you have a written exam and you pass the exam, but you didn't understand and you could not apply, and nevertheless you couldn't analyze what you were learning. So trying to come up in this pyramid, and you have the world's greatest pyramids in Cairo, so so it should be easy for you to come up to the red top to create for your students. So please use some taxonomy for your own understanding on which level you want the student to be on when they graduate. And of course, it's different for different courses in the program. Here's some I just added some more slides so you can have for your own work. I don't want to comment on this one. So this was a little bit shorter than the other one, and as we agreed, I should stop here, and we have a short break again, and then I'm coming back. A short 5-minute break, and then I'm coming back and have some news for you. So a short break.
Okay, thank you.
And for your understanding also, we stop recording here because these two sessions will be alone published, and the next session will be another recorded video.